Lesson 5-5, Solving Multi-Step Equations and Inequalities. So we are going to look at solving some inequalities. And when we hear inequality, that means not equal or possibly not equal. So that's where we see things like greater than, less than, greater than, or equal to, less than, or equal to. So there's that inequality. It's not identified as equal. So let's look at this example here. We have 4x minus 3 is greater than 6. So just like we would with a regular equation, we're going to distribute the 4. So we're going to have 4x minus 12 is greater than 6. So then you're going to add 12 to both sides because your ultimate goal is to always get the variable by itself. So you ask yourself, so we are left with 4x is greater than 18. You divide both sides by 4 and so you are left with x is greater than 4.5. So you're always able to check this because if you go back and you put x in, you replace the 4.5, you should get a number on the left that is greater than 6. So it makes the inequality true. If it does not make the inequality true, then you've made a mistake. So now we'll look at an example of a multi-step equation. And it's called an equation because that means that it results in an equal sign. So same thing, we distribute the 3. So we have 3d plus 6 equals 12. We subtract 6 from both sides. So we get 3d equals 2. And then you divide both sides by 3, which means that d equals 2/3. Pause the video to try a few examples. So for the first example, we have 3 equals 4 times x plus 2. You're going to distribute the 4. So we have 3 equals 4x plus 8. Okay, you need to identify what's happening and then undo it using order of operations backwards. So we subtract 8 from both sides, and so we have negative 5 equals 4x, and then you divide both sides by 4, so we are left with x equals negative 5/4 for our answer. For the next example is the same thing, but now it's an inequality. So we have 4b minus 12 is less than or equal to 72. Add 12 to both sides, and we get 4b is less than or equal to 84. Divide both sides by 4 to get the b by itself, and we get b is less than or equal to 21 as our final answer. Sometimes we also have what we call multi-step equations, and this is when we see things like this example that have a variable on both sides. So you want to solve each side of the equation first and then combine your like terms. So we're going to distribute our number into our parentheses on both sides. So we are left with 4x plus 20 equals 6x plus 12. My like terms are my 4x and my 6x. We want to identify, are those positive or negative? Since there's no sign in front of both of them, we would consider them positive. So we're going to combine them. So I'm going to move my 4x to the other side by subtracting it from both sides, because I get rid of it on the left and then I get a difference on the right of 2x plus 12. Going to do the same thing with the 12 because my goal is to always get the variable by itself. So I'm left with 2x equals 8. I divide both sides by 2 and I get x equals 4. As you recall from previous lessons, we can solve an inequality and then graph it to show us more of a visual of what numbers are represented in that inequality. So let's look at this example. 2p plus 5 is greater than or equal to 3 times p minus 6. So my 2p plus 5 is greater than or equal to stays the same. And then we just distribute our 3. So it becomes 3p minus 18. I identify my like terms as a positive 2p and a positive 3p. So I am going to subtract 2 from both sides because I don't want to have negatives. So I am left with 5 is greater than or equal to 1p minus 18. I'm going to add my 18 to both sides to get 23 is greater than or equal to 1p. So now I would be able to graph this. I'm going to flip it around and say that p is less than or equal to 23. So I have my graph. I plot some of my lines to signify my numbers. I make my positive 23. It's going to be a closed circle because it includes 23, and then it's all the numbers less than or to the left of 23. Sometimes when we solve equations, some of the equations they don't have a solution. And so when we do not get a solution as an answer, we write it's a null or an empty set or no solution. So an example of something that we might see is negative 14 is equal to 6. Once you solve all the way down, if you get something like this, you would say that this is no solution or it's a null because negative 14 is never equal to 6. And so you can also write it as an open circle with a line through it, meaning that there's no solutions, that this problem was not solvable. Other equations have every number as their solution. So sometimes we may get something that says 3 equals 3. Well, 3 is always equal to 3. So that means that this is identified as an identity, or you can say that it's all numbers because both sides are equal to each other, and so the answer would be identity or all numbers. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of completing this video.